Hello, thank you all for having me here today. I'm going to present to you my final findings for the Virginia Lottery sales drivers and North Carolina risk assessment. The data I used for this report includes lottery sales, number of retailers, travel time to work, population demographics, and socioeconomic information, including race, education levels, and income levels. And here I have two graphs from my last report showing the top 10 counties with the highest per capita lottery sales. And I included this because I'll be focusing in a lot on that per capita number along with regression for my report, and I wanted us to be familiar with some of those findings from the previous report. Here I have my regression results. This is a lot to look at, but I use regression because it allows for predictive modeling and allows us to see relationships between variables holding all else constant. So you can see down here I have all the variables. We have our coefficients and p-values. I'll explain those in some of the coming slides. And then I want to talk about this r squared here. This means that 63.5% of variation in our per capita sales is explained by our variable. And adjusted, it still explains for 59, and the standard error means that there's about $140.70 off that our predictions are, so it can vary by that amount. How significant is our data? This is using those p-values I mentioned before. If a p-value is less than 0.05, it means it's statistically significant, which means it's unlikely due to random chance. So we have three variables up here represented by the green that are statistically significant, and that'll be retail locations, percent non-white, and travel time. We have high school graduates as 0.059. It's very close in North Carolina border counties, and those will be included as well, even though they're not statistically significant. This is followed by the remainder of our variables that are not significant. We will not be talking about those for the remainder of the report. Using that information, we can see what our main drivers are and their effects. So again, these are those statistically significant variables followed by the other two. And we can see their coefficients here as well. The coefficients represent the expected change in the per capita sales when each variable increases by a single unit. So here we can see that the number one driver is retail locations with an expected change in per capita lottery sales of $185.90 for every additional store added, holding all else constant. Here we can see the relationship of percent non-white, travel time as well. These two have negative relationships, and we'll explain some of these on the next slides. Starting off, our number one driver is again that retail accessibility, and this had a coefficient of 185.9 that we just discussed. We can see the positive relationship as the number of retail locations per capita increases, so does the number of sales. You can see Emporia is way up here, very high sales, the most amount of retails per capita. Next we have our percent non-white. This did have the same statistical significance as number of retailers per capita, but it has a lot less of a strong effect on the per capita lottery sales, as shown by this slope here. Again, that had a 3.9 coefficient, and we can see the positive relationship is still affecting there. Next, we have our commute to work. Again, it was statistically significant, and this is a negative relationship, as we can see by the slope here. And this means that the longer it takes someone to travel to work, the less they spend on lottery per capita. This can be for many reasons. It can be reflecting being in a rural area. Perhaps someone doesn't want to stop on their way to work. It's out of the way, or it represents just the number of stores they can go to and their general accessibility. But there's many reasons that can explain this. Next, we have our education and its impacts on lottery sales. This was not significant, so I made this blue instead of green, as you can see. But again, this is a negative relationship. Had a negative 5.5 coefficient. And we can see that the higher the percent of graduates in a population, the less they spend on lottery. And lastly, we have our North Carolina impact. Here we can see our counties that border North Carolina and counties that do not border North Carolina, and the differences of per capita sales between them. You can see that counties that border North Carolina spend $165.70 more on the lottery than counties that don't. And we could see this through the 74.3 coefficient, meaning that lottery sales per capita increases by $74.30 if a county borders North Carolina. So what does this mean for North Carolina residents? And how does this impact the Virginia lottery if North Carolina adopts their own lottery? The regression model estimates that counties being on the North Carolina border increases per capita lottery sales by 74.31, holding all else constant. That was our coefficient from before. This number translates to $56 million in North Carolina cross-border lottery spending each year. You can find this by multiplying the total population of North Carolina border counties by that coefficient to find our cross-border sales. And this is the number that we can expect to lose if North Carolina adopts their own lottery system. In summary, while North Carolina cross-border shopping does impact lottery sales, it's not the main driver. So North Carolina adopting a lottery may impact the sales and those per capita numbers in those border counties, but it's not the main factor. Lottery sales is way more dependent on accessibility and demographic factors. Retailers per capita was the number one driver and number one cause of those high per capita sales. Here in the graph on the right, you can see the top 10 counties with the highest lottery sales by capita. This is the same graph from the beginning of my presentation, but I split it into not bordering North Carolina and bordering North Carolina. Here we can see that not bordering North Carolina has a higher per capita spending on lottery than counties bordering North Carolina. This goes to show that all the other variables, including retailers per capita, race, and education, impact lottery spending more than bordering North Carolina alone. Thank you.